All right, guys, Mr. Jenkins here with lesson 6.2, more about solving systems. This time we're going to look at using what's called the substitution method, right? So we know we've been through how to solve by graphing. We're looking for where the lines cross. And the next two lessons are about how to solve these algebraically, which I think you've seen before, but it may be new, okay? So we are gonna kind of consider the graphs because we learned about Desmos last time. So that's why you see that pulled up on my screen. And your learning target is I can solve systems of equations using substitution. All right. So let's go ahead and look at 1A. Solve each system using substitution. It says check your answer. Okay. So this is the part where I'm going to save you some work by showing you Desmos. Okay, if you haven't watched the video from Friday, I suggest you watch that for how to use this Desmos.com. Okay, and notice I went ahead and typed these in: y equals 3x, x plus y equals, that should be negative 32. Let me change that. So you got to be careful there. See, I made a mistake. So let me switch that to how it's supposed to be. Negative 32. All right, so there we go. So right off the bat then, I know my answer just by looking at Desmos is this point where the lines cross, which it will tell me is negative 8, negative 24, okay? Negative 8, comma, negative 24. So I'm going to go ahead and start with that. My answer is negative 8, comma, negative 24. All right, so we've already checked our answer. Now, on a test, if that's all you can give me, you might get 1 out of 5 points, right? So the big points are going to come in your ability to show the work, okay? So substitution is just like it sounds, right? You need to take something and substitute it. You need to have one or both of the variables solved for. So looking at my top equation, y is solved for. So I'm going to take 3x and plug it into the other equation. It's got to go in to the other equation for y. So right there. All right, so my step 1 is going to look like this. I have x plus, and then instead of y, I'm going to substitute 3x. You can see I put in a different color there, equals negative 32. And then I'm just going to solve for x, right? So x plus 3x is 4x. And negative 32 over 4 gives me negative 8, which we've already checked that. So we know our work is good. Okay, and then the only other thing you really need to show is now we sub this into either equation. All right, so in step 1, you have to go to the other equation. Step 2, you can do either. So we have an x value. Now we can use that to find y, right? So I can either sub in negative 8 there or there. It looks easier on the top, so that's what I'm going to do. Okay, so it's y equals 3 times x, which we know what that is now, negative 8. So I'm going to sub that in. So y equals negative 24, which we already know checks out. So I'm going to box in my answer. Now I've got the work to go with it. So this is going to be kind of counterintuitive, right? So your thought has been, usually in math, my work gets me to the answer. But now we're going to work from having the answer first. So kind of weird there, but hopefully it helps. Looking at the next example, example 2A, let me pull that up real quick. I'm always going to start with my Desmos graph first. So I know if I make a mistake at any point. All right, so we got 3y plus 4x equals 14. On here, that's the green line. And then we've got negative 2x plus y equals negative 3. On here, that's the purple line. I look at there to tell what the color is. Not that it really matters. So let's go ahead and figure out what is our solution. Okay, and looks like it's 2.3 comma 1.6. 2.3 comma 1.6. So this is where you get into like, you couldn't really solve these by graphing on your own probably, right? It'd be tough to come up with an answer like 2.3 comma 1.6. Oh, let me just mark that out. 2.3 comma 1.6. And I'm going to go ahead and just box that in because I know it's my final answer. All right, now you look at, these are a little bit tougher, right? So look at the top equation. You got 3y plus 4x equals 14. No variable is solved for. On the bottom one, negative 2x plus y equals negative 3. None are solved for, right? So in this case, you would want to solve for a variable. So it's nice to be, you could pick any variable. Like to solve for that y, you'd have to move over 4x and then divide everything by 3, right? So if you have a coefficient that is 1, that's the one you want to solve for. That's being the most efficient you could be. So we're going to rewrite this equation in terms of y. So we're going to rewrite it as y equals, when I move minus 2x over there, it's plus 2x. So 2x minus 3. Now I'm ready to make my initial substitution because y is solved for. Now it's important you remember, don't plug it in right there because that's going to give you an answer that's not correct. You have to plug it in for the other y. So it must go in right there, okay? So let's see what that looks like. So step 1 here, we've got 3 times y, all right? And that's our substitution. It's going to be 2x minus 3 plus 4 times x equals 14. Okay, now you've got quite an equation you have to solve here. Step 1 would be distribute. 3 times 2x is 6x. 3 times minus 3 is minus 9. And we just copy the rest. Combine like terms next. That's going to give me 10x minus 9 equals 14. Move over the minus 9, it'd be plus 9 on the other side. That's going to give me 10x equals whatever 14 plus 9 is. That's 23. And then 23 over 10 is 2.3. All right, so that's good news. We know our work is good. Without knowing our answer, you might assume you did something wrong because you got a decimal, but now we know that's actually correct. Okay, so that's a good thing. Step 2, we plug into either equation. So since y is by itself here, I'm going to sub into this one, but it doesn't really matter. So that would be negative 2 times x, which again we know at this point is 2.3, plus y equals negative 3. So that's negative 4.6 plus y equals negative 3. Add 4.6 to both sides to get y equals 1.6. So that checks out as well. Okay. So hopefully this is all making sense to you. All right. I am going to ask you a couple questions about now which variable would we want to solve for on some of these that are left to be able to make that initial substitution. Okay, but I'm only going to do one of these and move on just because you can rewind and whatnot. All right, so looking at example 3, the word problem. I'm going to tell you, if you don't get these word problems at first, as always, you know, people struggle with word problems. You know, we will spend a whole bunch of time on these. Okay, so this is kind of a look ahead a little bit. All right, so this says a snack bar sells 2 sizes of snack packs. A large pack is $5 and a small pack is $3. In a day, the snack bar sold 60 snack packs for a total of 220. How many small packs did the bar sell? Okay, so let's go ahead and define our variables. So let's use X and Y. We'll say X is number of smalls. You could flip-flop these, it doesn't matter, but you need to know what's what. And then Y is the number of big. Okay, so with this type of problem, you're going to have one equation set to 60. So that's for our total, all right? So our total sold is just going to be some number of smalls plus some number of bigs equals 60. And then our other one's going to be for the money. Here's where you bring in your coefficients, right? So it's $3 per small pack. So we're going to do that's 3x plus $5 per big pack. So 5y, and then we raise 220. Okay. So you'll see when I pull up my graph here. $5x plus 3y. Okay, I flip-flopped them. Let me fix that too. I did x was the large pack, and so let me make that look a little better. I'm gonna flip-flop my coefficients. I'll make that 3x plus 5y. All right, so as you can see, I have both equations typed in. X plus y equals 60, 3x plus 5y equals 220. And now my point of intersection is off my graph a little bit, but you can always grab the screen and move it around. Desmos is really user-friendly. So it looks like they intersect at 40, 20. And then you just want to make sure you pick the right one, right? So what are we looking for? Small packs, right? So we said X is the number of smalls, so that should be 40 smalls and 20 large, right? So really, we've done enough there on a test for you to get full credit there. That said, I'm going to go ahead and show this by substitution just because I've skipped several examples. All right, so if you're going to do this by substitution, notice that no variable is already solved for. So I'm just going to pick like this, this x right here. Let's solve for that x and see what happens. When we do, we get y equals negative x plus 60. And then you're ready to sub. Got to go into the other equation for y. All right, I'm going to start working in this space down here now. So again, we already know our answer. I'm just showing you the work that goes with it. So we have 3 times x plus 5 times y, which we've set equal to negative x plus 60. And equals 220. So distribute first, we get 3x minus 5x plus, that'd be 300, equals 220. Combine your like terms, that's negative 2x. Now we'd want to move over the plus 300, so we get negative 2x equals, that'd be negative 80. And then x equals negative 80 over negative 2 is 40, right? So obviously that matches our answer and just kind of confirms everything, right? So again, for a test, what I would be looking for on these word problems is more your ability to write your system, and then you could just use Desmos to produce the answer, okay? All right, so your last type of question that I want to look at with you are these IMS and no solution, right? So what's that look like? You know, using substitution and using Desmos, okay? So I'm going to skip ahead to example B here. So again, I'm going to start with my graph. I'm going to know my answer going in before I start to do any work. So let's see, looking for 6.2, example 4. All right, so I'm way zoomed out right now. Let me zoom in a little bit so it's a little more clear. Okay, so you see I typed it just like I saw it. Y equals 3x minus 11. Y minus 3x equals negative 13. Okay, and what we see here are, what appear to be parallel lines. So we see no point of intersection. So it appears that this system has no solution. So I'll go ahead and write that. All right, and now we want to, get the work together that proves that. The nice thing is the top equation's already solved for y, so we're ready to go ahead and make that initial substitution. So it goes right there. So step 1 is going to look like this. Instead of y, we're going to sub 3x minus 11. And then we have minus 3x equals negative 13. Combine your like terms. On this side, 3x minus 3x is 0. So really this just says negative 11 equals negative 13. Sorry, that should be equals. There are no variables left to balance this out, and it's not true. So this work now matches this answer. Okay, so it is very nice to be able to know your answer going in, as long as you're able to do 2 things on Desmos. Well, 3 things. Get to Desmos, that's 1. Then type in your equations correctly, that's 2. And then step 3, probably the most important step, is interpret what you see. Okay, interpret what you see. So as you can see, I have skipped several examples. I tried to make this a little bit quicker video. If you are struggling, just pick an example in class that you want to see, and I'll happily show it as just kind of some extra examples that hopefully can help you to better understand. Okay, so we'll spend a couple days on this, and hopefully you guys pick up on it pretty well.